So remember yesterday we talked about a shocking discovery from the James Webb Space Telescope, one of the oldest and most massive galaxies ever observed? It was so big and so mature that it seemed to appear far earlier than our models predicted. Honestly, that discovery alone was enough to make scientists pause and rethink some of our assumptions about how the early universe was formed. Well, surprisingly, that might have only been the beginning. Because in the newest deep space images coming from the James Webb Space Telescope, scientists are starting to notice something even more surprising. Not just one strange object, but a growing pattern of observations that don't quite fit the rules we thought the universe followed. In fact, these new findings suggest the universe might not work exactly the way we believed it did. Astronomers are now spotting unusual signals and structures in Webb's data, clues that are beginning to challenge some of the most fundamental ideas in cosmology. Ideas about dark matter, dark energy, and even the mysterious origin of the cosmic microwave background. And if these observations continue to happen, then we can all agree that our cosmological model has to be rewritten. Now, there are a few important ideas you need to understand. According to the laws of gravity, the farther you move away from something, the weaker its gravitational pull becomes. Take our solar system as an example. The Sun pulls much more strongly on Mercury, which is close to it, than on distant objects like Pluto or those at the far edge of the solar system. And this rule doesn't only apply to our solar system. It works the same way everywhere in the universe, from stars and galaxies all the way to massive black holes. But in the late 1900s, scientists came across something that didn't quite make sense. When astronomers started studying galaxies more closely, especially during the 1970s, astronomer Vera Rubin noticed something strange. The stars located far from the center of galaxies were moving just as fast as the stars much closer to the core. That is surprising, right? Because this shouldn't happen. If stars at the outer edges of a galaxy were really moving that fast, you would expect them to drift away into space, similar to how water flies outward from a spinning wheel. The reason is simple. Gravity should be much weaker than far from the center of the galaxy. And yet, those stars stayed right where they were. They didn't fly off. This strange behavior suggests that something else must be adding extra gravity, which helps to keep those stars in their fast paths around the galaxy. As scientists collected more data, they began to suspect that something invisible was influencing everything behind the scenes. They gave this mysterious idea a name: dark matter. In this context, dark matter simply means something we cannot see, but whose effects we can observe. Even today, no one knows exactly what dark matter is made of, but many observations show that it likely played a major role in how galaxies formed and grew over time. In fact, dark matter helps explain how the universe developed the way it did. According to the lambda CDM model, shortly after the Big Bang created normal matter, dark matter began pulling that matter together through gravity. Over billions of years, stars and galaxies slowly formed and expanded inside huge regions known as dark matter halos. Even the large-scale structure of the universe, the vast network of galaxies, clusters, and cosmic filaments we see today, was shaped by dark matter. In many ways, it acted like an invisible framework that allowed normal matter to gather together and eventually form galaxies. Even the tiny temperature patterns we see in the cosmic microwave background carry clear clues about the role dark matter played in the early universe. But something surprising has recently appeared. New discoveries from Webb are starting to challenge many of the ideas scientists believed were settled. In fact, these findings are raising serious questions about dark matter itself. It could mean that we've misunderstood dark matter all along, or, in the most extreme case, it might suggest that it doesn't exist the way we think it does. When scientists examined the newest images from the telescope, they began finding galaxies at incredibly large distances. The farther they look into the early universe, the more galaxies seem to appear, almost as if they just keep going. And that creates a big problem for the current dark matter model. According to our theories, galaxies should not have formed so quickly in the early universe. One of the most distant confirmed galaxies discovered so far is MOM Z14. It already existed when the universe was less than about 280 million years old. Even more surprising, scientists have found possible galaxy candidates with redshift values of 20 or even higher. If these observations are confirmed, it would mean those galaxies formed when the universe was only around 200 million years old. Right now, these objects are still being studied, and scientists need more evidence before confirming them. But if they turn out to be real, they could push our current theories to their limits. What's even more surprising is what these early galaxies actually look like. Many of them already appear well-formed, similar in structure to our own galaxy, the Milky Way. Scientists expected the first galaxies to be small, messy, and chaotic. But instead, some of these galaxies seem large and surprisingly organized. A few even show signs of older stars. In some cases, they are even bigger than the Milky Way. One galaxy called J0107a is estimated to be about 10 times larger than our own galaxy. What makes this even more astonishing is that it existed when the universe was only a few hundred million years old. Right now, it stands as the largest Milky Way-like galaxy we've seen from that early period of the universe. Discoveries like these are making scientists uneasy. For a long time, researchers believed dark matter was the key ingredient that helped galaxies form and grow. But now, the same theory is struggling to explain how these massive and mature galaxies could appear so early in cosmic history. So scientists are facing a difficult possibility. Either our understanding of dark matter is missing something important, or what we call dark matter might be something very different from what we currently imagine, something that behaves in ways our theories don't yet describe. And the mystery doesn't stop there. These distant galaxies are only part of the puzzle. Observations from the James Webb Telescope are also revealing something even stranger happening in the universe, something that dark matter alone cannot explain. Scientists have also discovered something unusual about the largest structures in the universe, things like galaxy clusters and the enormous cosmic filaments that connect them. These giant structures seem to have formed in ways that don't fully match what our current theories predicted. This mystery has become one of the biggest problems in modern cosmology, and scientists call it the S8 tension. The value S8 describes how strongly matter is clumped together across the universe, especially on very large scales. In simple terms, it helps scientists understand how galaxies and galaxy clusters are spread throughout space and how these structures grew over time. But here's where things start to get strange. When researchers study the early universe using data from the cosmic microwave background, they calculate one value for S8 based on the current cosmological model. However, when astronomers look at the present-day universe, observing how galaxies are actually grouped together, they get a noticeably lower value. At first glance, the difference might not seem very large, but the important point is that the gap appears again and again in different measurements. Because of this consistency, scientists believe it's unlikely to be just a simple mistake or random noise in the data. So what could be causing it? Some researchers think there may be small problems with the measurements themselves, but many others believe the answer might be deeper, that something important about the universe is still missing from our understanding. And now the questions don't stop with dark matter. Observations from the James Webb Space Telescope are also raising new doubts about another mysterious component of the universe, dark energy, the force scientists think is responsible for the universe expanding faster and faster. Recently, researchers have noticed major differences in how we measure the expansion rate of the universe, known as the Hubble constant. When scientists calculate this value using information from the cosmic microwave background, they get one result. But when they measure it using exploding stars called supernovae and other nearby observations, they end up with a completely different number. This disagreement is known as the Hubble tension, and it has become another major puzzle in cosmology. And there's an even more surprising possibility. Some recent studies suggest that dark energy might not actually be constant, even though scientists have believed that for decades. Instead, it could be something that slowly changes over time, something we still don't fully understand. But the surprises don't end there. In fact, the mystery might go even deeper. Ever since the discovery of the cosmic microwave background, many scientists have believed that the Big Bang theory must be correct, that the universe had a clear beginning. The cosmic microwave background was thought to be the oldest light in the universe, a faint glow left behind from the early moments after the Big Bang. Its properties match very closely with what the Big Bang model predicts. But now, a new line of research is suggesting something shocking. It proposes that the cosmic microwave background might not actually be the afterglow of the Big Bang at all. In this new study, researchers suggest that what we've been calling the oldest light from the Big Bang might actually come from a different source. Instead of being leftover radiation from the birth of the universe, part of it, or maybe even all of it, could come from galaxies that formed very early in cosmic history. In the study, scientists focused on a type of galaxy known as early-type galaxies. These galaxies, especially in their early stages, would have contained large numbers of young, extremely hot stars that release huge amounts of radiation. Now imagine billions of these galaxies spread across the universe. If enough of them existed close together, their combined radiation could fill space with a faint glow. Over billions of years, as the universe continued to expand, that radiation would stretch and shift toward longer wavelengths. Eventually, it could become redshifted so much that it begins to resemble the signal we identify today as the cosmic microwave background. If that idea is correct, then the CMB might not actually be the leftover glow from the Big Bang theory. Instead, it might partly, or possibly largely, come from the combined radiation of countless early galaxies. According to the study, the energy contributed by these massive galaxies to the background signal isn't insignificant. Researchers estimate that they could account for about 1.4% of the total energy measured in the CMB today. That number may seem small, but it's large enough to influence how scientists interpret the data, especially as measurements become more precise. And that figure is considered a conservative estimate. If scientists include other types of early galaxies in the calculation, the contribution could be even high. If early galaxies are adding a meaningful amount of radiation to the CMB, or in the most extreme case, if they are the main source of it, then the foundation for using the CMB as evidence of the Big Bang would become much less certain. Scientists would have to reconsider many of the conclusions built on that assumption, including the age of the universe, how cosmic structures formed, and the physical processes that shaped the early cosmos. And this is only one of several discoveries now challenging our understanding of the universe. Observations from JWST are forcing scientists to re-examine some of the most important ideas in cosmology. From dark matter and dark energy to the cosmic microwave background itself, many long-standing assumptions are now being questioned. These findings suggest that we might still be missing an important piece of the cosmic puzzle, or that the universe behaves very differently from what we once believed. But the surprises don't stop there. The Webb telescope is not only challenging existing theories, it's also revealing strange clues that hint at something even more extraordinary. One possibility being explored is the idea that the entire universe might exist inside a gigantic black hole. In a recent observation of about 30,000 galaxies using JWST, scientists noticed something unexpected. Many of these galaxies appear to rotate in the same direction. This is extremely unusual. According to the Big Bang model, the universe should have formed in a chaotic way, meaning galaxies should spin in random directions. But the pattern seen in these observations suggests something different. It hints that the universe might have started with a kind of initial spin, something that current cosmological models do not predict. To investigate this further, a research team led by Lior Shamir measured the redshift of more than 30,000 galaxies. What they found was surprising. The farther back in time they looked, the stronger the imbalance in galaxy rotation appeared to be. In other words, in the earliest periods of the universe, galaxies seemed even more aligned in how they were spinning. This is difficult to explain using current cosmological theories. If future observations confirm these results, scientists may have to rethink some of the most basic assumptions about the universe. It could even suggest that new physics, beyond the ideas developed by Albert Einstein, may be needed. After these remarkable discoveries, another study has proposed an even more radical idea. Research published in the journal Physical Review by scientists at the University of Portsmouth suggests that our universe might actually exist inside a black hole. According to this theory, the universe may have formed during a massive gravitational collapse that created a black hole. If true, this idea challenges the traditional Big Bang picture, which states that the universe began from an extremely dense point and rapidly expanded outward. According to Enrique Gastañaga, when matter collapses under gravity, it doesn't always end in a point with infinite density. Instead, the collapse can reach an extremely dense state and then rebound, creating the conditions for a brand new, expanding universe. In this picture, what we think of as the edge of our universe could actually be the event horizon of a giant black hole, the boundary beyond which we cannot see anything outside. If this idea is correct, it means the universe may not have appeared from nothing. Instead, it could be part of a repeating process of collapse and rebirth, a cosmic cycle that continues again and again. Interestingly, this concept shares similarities with a theory known as conformal cyclic cosmology, proposed by Nobel Prize winner Roger Penrose. In Penrose's view, the Big Bang theory was not the true beginning of everything. Rather, our universe may simply be one phase in a long sequence of cosmic cycles. Each cycle, sometimes called an eon, eventually stretches out into an extremely empty state, which then gives rise to the next universe. In other words, there may have been universes before ours, and there could be more after it. Ideas like these are still being explored, but they show how quickly our understanding of the cosmos is evolving. Many of the discoveries made with the James Webb Space Telescope are opening new questions about the nature of the universe and how it truly began. And these findings may only be the beginning. As Webb continues to observe the distant universe with unprecedented detail, it may reveal even more clues, bringing us closer to understanding the true story of our cosmic origins. That's it for this video. We hope you enjoyed the journey. If you enjoyed the video and want to support our work, you can do so by clicking Super Thanks.